Hey all, I'm gonna give everyone a couple minutes to get in and get settled, but if you want to have extra credit for today, you can go ahead and go to our GitHub repo, which I will put the link in the chat here. And in that README, you can find the heading for today's class and then download and sign up for the resources that are listed there. So go ahead and get started, and we'll get the class going in a couple seconds here. Hey everyone, if you're just logging on, I am putting a GitHub link in the chat, and then also you can see it on my slide here. Go ahead and find the heading for today's class in our GitHub page, and we'll be getting started shortly with that. So if you open our GitHub page here, scroll down, and you should eventually find workshop schedule, and then under week 1, we've got Wednesday. Well, I guess we can go ahead and get started. Umang, did you want to say anything at the top, or should I just go ahead and go?
Go for it.
All right. Welcome back, everyone. Let me get back to our top. All right. Hello, everyone. Welcome back to AI Summer. Super glad to see that you returned. So today we will be talking about AI security. So we get a lot of questions, especially when we're doing AI-assisted programming. How can we use these models securely? We talked a lot about that in the office hours later. So today your host will be me, Miranda Shirk, and Umang Chaudhry, who is another senior data scientist on our data science team. Just for reference, though, here are some of your other hosts that you will have throughout the summer. Today is actually my last day hosting, so believe next week you'll hear from Jesse Spencer-Smith and a couple of others. So really happy to be doing this today, and feel free to reach out to any of us if you're having issues or questions throughout AI Summer. All right, so for today, you may have seen this before, but I'm going to give people, just a couple extra seconds to get this done. So for today, go ahead and go to our GitHub repo. This is just a great resource to have anyway, because it's where we will be posting our workshop recordings. I think I mistakenly said we would use YouTube last time, which maybe eventually they'll make their way to YouTube. But for the most immediate access to our AI Summer courses, if you miss a day or you just want to review the material, you can head on over to our GitHub page. It will look like, not that, this. So when you first click on it, it'll look something like this. You'll see AI Summer. These are some of the files that we have on there, but don't worry about that. You can scroll on down and see the schedules. So here's just some nice resources, but then you'll find workshop schedule and recordings, right? So under week 1, we've got Monday and Wednesday, and underneath Wednesday, notice I want you to go ahead and download LM Studio if you would like. If you don't want to download it, that's totally fine. I will be showing you how to use it. So it might be more fun if you have it yourself. And then also to follow along with a notebook we'll be doing, go ahead and register an account on Hugging Face and generate an API token. And I have some instructions there, but let me show that real quick. So huggingface.co, it's a very nice a collection of models, transformers models, and documentations. We will be using this probably a lot during AI Summer, so it's good to go ahead and get yourself an account. So sign up for an account on Hugging Face, and then to get an API key, I have the instructions on on the slide or on the GitHub, but just for you to see, I click on my little circle here, that's my profile, go over to access tokens. It's called access tokens. Click on that and it should take you. So these are some of my tokens. If you haven't created one, yours will be blank. And then create new token. It'll show up with all these options, but an easy way to just create one is hit on this write button. That just gives you blanket write permissions, which is totally fine for our workshop. And then give yourself a token name and create the token. Now this will pop up with your API key, which we'll talk about what those are in a second. This will pop up with your API key. Save that because it will never show it to you again. So hopefully you're able to do that in my short little intro here. All right. And as always, please feel free to put questions in the chat. I can't always see the chat while I'm presenting, but we have some other people on Zoom that are able to answer those or point those to my attention. Okay, just giving people, I'm just stalling here so you can do those things before we get started. And also as a bit more of a stall, from last time, don't worry, those instructions are still there if you want them. But from last time, I'm really curious if anyone had any ideas from their breakout groups. Maybe you worked a little bit yesterday on the app you tried to create, or you just had general comments or observations on what you've seen so far. Feel free to raise your hand, unmute, put in the chat. I'm really interested to know if you had any ideas or observations from what we worked on last time. Anyone try out Replit or Windsurf and have some interesting results happen? Okay, wonderful. We got the app to work. I love that. Yeah, sometimes you got to watch out for some weird settings on there. Yes, yeah, so you can use cursor. Cursor is also a great option. I've kind of been trying to decide between cursor and windsurf. So both of those are really good options. Anyone else have some observations from last time? Maybe you tried some more app stuff, or maybe you have questions from last time. Tried windsurf. Okay, impressive and underwhelming. Okay, I'm interested to know what part of it was underwhelming. I love the honesty. I love the honesty. All right, great. Well, I'm gonna go ahead and, oh, the code wouldn't work. Oh, that's not great. Sometimes that happens. Great. Okay, so that's wonderful. I'm happy to hear, and feel free to keep putting in the chat if you have other ideas or things that happened with you from what we worked on last time. But let's go ahead and get into it today. So we're going to be talking about AI security. I think a lot of people are looking, we have a mix of people that really want to talk about security all the time, and then people that are like, I'm just going to ignore it and pretend like it's not a problem. And so we're gonna talk about security today, and we're even going to, I think, do I have the schedule? Okay. So AI security, let me give you an example of some kind of problem that happens with AI. And maybe this was some hallucination in your code that happened, Daniel, but let me give you an example. So have any of you ever asked ChatGPT to write code for you and it hallucinates some sort of package or function name? Like it just tells you to use like blibbity blop package, and that blibbity blop package like does not exist at all, right? But it's like, oh, just use this and it'll work. Has that ever happened to anyone? Um, Probably. I know it's happened to me a lot. And so what it does is it kind of chooses something that sounds like it works. Maybe it's seen at like something named somewhere, and then it's just going to give you that code. So now imagine a new generation of hackers noticing that maybe ChatGPT kind of hallucinates similar names over and over again. Like maybe if you want to plot something, it's going to hallucinate some random package name called like easy plot or something. Now someone can take note of that, quickly put a package on Python that's called EasyPlot or whatever name they want that's very common, and install malware onto that package. So now when ChatGPT, or even scarier, something like Windsurf or Cursor that's directly onto your computer, imports these packages for you, it's actually importing malware. And you have no idea because the documentation maybe looks okay, because someone maybe could put like a thing on there that makes it look convincing. But it's really just there with the intention of an LLM to hallucinate it, right? That's really terrifying because that's really hard to catch, especially if maybe you're not as familiar with programming. Even if you are more familiar with it, just being able to these LLMs downloading these packages for you, and could actually just download a virus onto your computer. That's really scary. And those hackers didn't have to do anything, right? They didn't have to convince you to download their code. They didn't even share the code with you. They could just put up a web page that's accessible to LLMs, and then the LLMs just use it because it says this is a beautiful package for plotting. Definitely not a virus at all, right? And the LLMs are just going to use it, right? So this is pretty crazy. And this, I think it's called, oh, it has a funny name. I'm trying to remember what it's called, like Snope scoping. I don't know. So it has some sort of weird name now, but that's this new hacking technique that people have been reporting on. And so I have some example code here that Windsurf generated for me. And so it's importing these libraries, it's logging in, it's getting my API key. And unless I'm familiar with this package, how do I know that this is getting a lot of information from me and it's downloading to my local computer? So how do I know to trust this generated code, right? We're logging in, I'm going to put in a password or something, and then I'm going to download a list of models. Like that is really scary if I don't know what this code is. So how do we securely code with AI is basically the question for the day, right? We're going to look at a bunch of different lenses, a bunch of different resources you can use. And so here's our schedule at a glance. First, we'll kick off by I will talk about Amplify at Vanderbilt. This is a Vanderbilt-wide generative AI platform for us. So if you're not Vanderbilt, please stick around and maybe just kind of see what we've got and see if you want to incorporate that yourself. But this will primarily be for the Vanderbilt folks just for about 10 minutes or so. Next, we're going to talk about API keys and best practices, security levels at Vanderbilt, and local inferencing from Umang. And then after the break, we're going to look at some local inferencing options such as LM Studio or something called Ollama. And then we're going to have a fantastic guest presentation by VUIT to talk about their perspective on incorporating AI into your work. All right, so let's go ahead and get started. So Amplify, if you go to vanderbilt.ai, it is a very easy easy URL there, vanderbilt.ai, and you have to be at Vanderbilt or have a Vanderbilt account to use this. So if you're interested in seeing what we've set up at Vanderbilt and maybe you want to set up something like that at your institution if you're outside of Vanderbilt, please stick around and feel free to still ask questions about it and engage with it. And you can kind of watch what I do. But if you're at Vanderbilt or you're associated with Vanderbilt, you should be able to go here and log in, create an account with your Vanderbilt credentials. So this is a platform, it's called Amplify, and Vanderbilt was actually, as far as I know, one of the first universities to roll out a large generative AI platform for the entire community. And so this is very secure. It's just restricted to Vanderbilt access. Of course, there's different levels of data access that Umang will talk about later that maybe will determine whether or not you could use Amplify for your specific situation. But I believe we have some sort of contract with the LLMs that they're not going to train on our data, and it's all going to stay internal within Vanderbilt. So I really love something like that. And so you can have custom assistants, custom prompts. There's a lot of tools on Amplify. So let's go ahead and take a look at it. So yeah, we've got lots of stuff on here. So I'm gonna just go ahead and log in. So vanderbilt.ai, and it's logging in with my Vanderbilt single sign-on. And here we are. So this is what it looks like when you first log in, start a new conversation, and look at all these models. This is beautiful. We can choose from so many different models. So if you prefer Claude, you want mixed role, mixture of experts, maybe you want GPT, and we've got even access to Turbo 4.0 and 4.0 Mini. So I'm going to select Claude 3.5 Sonnet. You can add in some custom instructions. We'll look at this toolbar over here in a second, but you can add in some custom instructions, and then you can even vary. This is called the temperature of a model. Maybe we'll get into a little bit of what that means, but basically this toolbar says it all. So if I want something that's kind of neutral, if I want more creative, or maybe I want something really precise, right? I'm gonna have it on neutral here, but then we even have this response length, right? So if I want very long responses or I want really short responses, totally fine. So if I start this here, now I can chat with Amplify. So maybe I want to say, you know, generate code that simulates student grade data or something like that. And now it's going to write that code for me using Claude 3.5 Sonnet. Right, and so you can imagine using this for your various projects that maybe you want to keep more secure, right? But what is really cool about Amplify is this toolbar over here. And so so it has some pre-created assistants here. So we've got Amplify helpers. They have a create visualization helper that you can start up to help you create some data visualizations. We have some custom instructions. So if you see this, PowerPoint assistant, this set of custom instructions helps create slide outlines that can then be exported with slide templates. That's super cool. And then some sort of diagram assistant as well. We've got API assistants, API key managers, which is wonderful. So if you want to be a super user of this, you want Amplify to create applications for you that use an API key. So like the Hugging Face API key we talked about earlier, you can actually manage your API key here, store it on Amplify, and it has permission to use it for you. I have not myself used that yet, but it's super cool if you're interested in creating more of a like GUI type, like user interface type thing with your chat agents, but you also want it to have access to API keys for you. Super cool stuff. I also like this. You can create a prompt template. So if you have a specific prompt type that really works for you and you're really tired of typing it all up or copy and pasting it all the time, you can put your prompt right here and even use curly braces to insert some sort of variable that you maybe want to change. So maybe you want to say, I want to generate slides for this class, right? And then you can change that every time you enter that prompt. You can just say, okay, what variable are you changing here? Lots of different kinds of stuff. So if we put in default instructions, visualization assistant, you can really customize this to your liking and then use that prompt when you interact with the model. So this is wonderful. It's kind of like if you think of ChatGPT and the custom GPTs, but just for Vanderbilt and with a lot of pre-made stuff specifically for the Vanderbilt use case. So just really cool. And I'm going to see if there's any questions. Yes, and actually someone says, oh, I wonder if we could talk about what an API is. And actually that's next on the schedule. So thanks so much for beating me to it. But so that's kind of an overview of Amplify. If you want more, we have a lot of resources on Amplify or just play around with it yourself. I don't want to take too much time on it just so that we don't exclude our non-Vanderbilt fellows who are joining us here. But a really great tool if you're looking for security. All right, let's talk about API keys because that's been requested. So what are API keys and what is an API in general? So an API key is a unique password or identifier for accessing applications or an API. API stands for Application Programming Interface. So whenever you are using code to access some sort of service like Hugging Face that gives you access to large language models to use in your own code, that's an Application Programming Interface, API. And what Hugging Face requires of you and what many APIs require of you is a unique identifier so that they know who's accessing their applications. You can imagine they don't want just anyone. They don't want bots accessing it. So they want to make sure that each API is associated with one user. They know who you are. And if there's some sort of billing, then they can bill you for your use, right? And so it's kind of like a password / identifier for your account. What is different from a password versus an API key is that an API key is generated for you by the app that you're using. This is, like I said, it's an identifier. They don't want you to set this and then change it, right? It's never going to change unless you delete it and create a new one. But for example, Hugging Face, some sort of AWS, if you're accessing AWS from your Python code, also Google Maps API is what we're looking at here. They identify you when using an application, and sometimes this can be linked to billing. For example, if there's some sort of like AWS, you usually have to set up a billing account for, and this way it can keep track of how many resources you use and and when you use them, right? So let's talk about storing API keys. And now, so API keys are very long strings, and they're impossible to remember. You could not remember this by yourself unless you have some sort of special talent for that. So how should you store your key? And a lot of API keys will only show your key once. It'll show it to you on the screen once. It'll say, save this, because this is the only time you're ever going to see it. And you better listen to that because they mean it. Even if you say, I forgot my API key, they'll say, oh, sorry, you're just going to delete it and create a new one. So my top recommendation for storing API keys is with a password manager. I recommend a password manager anyway for any of your general passwords. I think it's great. But basically a password manager is some sort of software. I have one that's in my Chrome extensions called Bitwarden, so I recommend that one. But it basically just keeps your passwords for you. You remember one password to access your account, and then it has all your passwords for you. You can choose to keep this local on your computer or store it with that software. So Bitwarden and 1Password are very popular for this. Another option is using secrets. So other softwares where you keep your code have what's called secret managers where you can store your API keys, kind of like an Amplify where it offered an API key storage system there. GitHub, AWS, Microsoft Azure, and Google all offer secret management. I think even Hugging Face offers this, maybe LangChain maybe offers it as well. But it's basically just the software where your code is. You can keep track of your API keys there if that's what you prefer. And then finally, maybe last resort is some sort of local file on your computer that you're never going to share with anyone and never delete, right? So we can see why maybe we don't want it on a local file, but if that's what your preference is, that's fine. Just make sure you don't lose it and make sure you don't share it. Okay, so let's look at an example here. I'm going to do this quickly, but if you go to our GitHub here, you should be able to see this API keys notebook. For some reason, I accidentally put on two. They're the exact same. It's just one has a dash and one has an underscore, and I don't know how that happened. But if you click on the one with an underscore, you have a link to Colab where this will actually open it for you in your browser if you prefer it that way. You can also download it and open it in Windsurf. So I'm actually going to open mine in Windsurf and just show you really quickly. So this is basically just what I've been saying about API keys so far. But let's look at some of the most common mistakes I see with API keys. So for instance, here we go. Storing your API key, you say, okay, well, this is my Jupyter notebook that I'm keeping on my computer. It doesn't matter if I type it directly into here. And then I'm going to type my example API key directly into here, and then I'm going to assign it to an environment variable on my computer, and that's totally fine. All right, something is wrong with this, and that's that you've typed your API key directly into here. Now, what if you're on a collaborative project and you're working in GitHub, for example, and now you're going to commit your work and push it for your entire team to see, and now your API key is exposed to whoever you're collaborating with on GitHub, right? Another variation of this that I see often from my students is that they'll say, okay, I'll type it in here and then I'll erase it. And then after I already get this output, I'll erase it and that's fine. And now I'll save it and now I'll upload it to GitHub. That's also a problem because usually you forget to erase it. Right, you're gonna type in your API key, run whatever you need to run here, save it, and then get rid of it. That's a lot of steps, right? And we are programmers and we're good at automating things. So let's just automate this process maybe, or make it a little better, right? Here's another iteration of this is maybe you're sending it, you're not assigning it to a variable or something, you're just sending it directly using some sort of request library. So this is where I'm putting my API key to this URL and I'm saying, okay, well now it's hidden in this thing, but you still have a variable where you typed in your API key here. This is not great. So very quickly, I'm just going to show you how maybe you should do this. And if you are experienced programmers in the room today, I think you will still be tempted to do this. I am still tempted to just type out my API key. I see it all the time with professionals. Don't do this. You will be tempted to. I know some of you are thinking, oh, Miranda, I am very good at security and I will never do. I guarantee you, you will try to do this at some point. So let's look at some best practices so we can all avoid it. One super easy one is called GetPass. So GetPass is just a password entering system in Python. You can install it using pip install getpass. And what this is going to do, see if my, oh, yep, it's running. So I've got, oops, my password manager. Don't worry about that. I've got my password manager here for, where did it go? Oh, this is just an example and I was like, what is this API key? But so I'm going to enter something here. Notice that it popped up with this little form filler here, right? And so this thing is going to keep running until I enter something and press enter. And now it's going to assign my API key to this environmental variable. Now, oops, I didn't run the previous cell, so OS is not defined, but that's fine. This wouldn't have really worked anyway because it's an example. But if I type something in, and now it's assigned that to my API key. So I recommend GetPass, especially if you just want an easy solution. There's also, like I said, softwares where you can set up key management systems and stuff. But let's take a quick look at a real example in Hugging Face. So this is the portion of it where you can follow along if you would like. If you already got your Hugging Face token, you can test to see if it works here. But here is where I recommend we're going to get the Hugging Face API, import OS, that's just something we'll use, and then import getPass as well. So now getPass is going to prompt us for our Hugging Face token. Oh, and Windsurf is trying to recommend things to me that I don't want it to recommend. But so let's go ahead. If I run this, it's going to prompt me for my Hugging Face API token. Once I enter that, it will show me these models. So I've asked it to access the API and then list models, filter it based on text classification. And Windsurf, maybe this is one downside. Windsurf is like, oh, what if we just crossed this out? That's a good suggestion. I don't know why it's suggesting that, but, and then I'm going to list out these models. So anyway, let me get my Hugging Face API key, and I'm gonna give you just a little glimpse into what I'm doing here. So I have a password manager, that's what it looks like. And I can look up Hugging Face, Hugging Face. This is the one I want to use. And then I can hit copy password. And so you guys didn't even see it. I just copied it. And now I'm going to paste it into the terminal here. All right, let's move this back down. Okay, so now I'm going to paste it in here. And depending on your IDE, this will either pop up here or up here somewhere or in a terminal. So if it's just running and you have getPass, try to figure out where it's going. And it worked. So now I've entered my API key. It's going to automatically put that into what's called an environment variable. And now it's going to list out all of the models here. So that was my just very quick and dirty example on how to work with API keys. This is just, like I said, very quick option. If you're still unsure a little bit about API keys, we have some other resources you can look at. Feel free to go over the notebook a little more and ask me if you have any questions. I didn't want to spend too long on it, but that is probably some best practices for managing these API keys. So I'm going to pause and see if anyone has any questions. Otherwise, we're going to move on to our next section. So someone's asking, how do we access the course information in GitHub? So if you follow the link to Vanderbilt Data Science, yeah, that link that Umang just put in there, you should be able to see all the course information there. Yeah, someone put in a really great tip on enabling dual authentication on something like AWS, because yeah, people can just really wreck your credit card if someone steals it. All right, perfect. Well, now that we're all API masters, we are going to move on to the next portion of this, where Umang is going to take us through some details with security and also some small models. So I'm going to stop sharing so that Umang can start.
All right. Hello, everyone. My name is Umang once again, and I will quickly go over how to work with AI when working with secure data. And the presentation that I'm about to share is also available on the GitHub repository, so you can also download that and follow along. Can you all see the presentation?
Yep.
Cool. Awesome. So, working with local models. So, we've been talking about this a lot. It is very, very important to be cognizant of the kind of information we're sharing with large language models, especially when they're running somewhere on a server where we have no idea what they're doing with the data. So, the couple of things that I'll talk about is just how to identify what secure data looks like, and then depending on what that data is, how to proceed further with using these models. And in the scenario where you quickly figure out that, hey, I can't use ChatGPT or any of these online models because, I'm using HIPAA data or something like that. I need to do these things locally or just use a different approach. And so I'll quickly talk about how you can run large language models locally, how you can train them locally, and how you can just host them locally for, other apps that you may have built to use. And for that specifically, we'll look at Hugging Face, LM Studio, and Ollama. I'll quickly introduce LM Studio and Ollama, but I believe Miranda will kind of go into the details of how those work. If you haven't already downloaded them, I'll put these links in the chat real quick. You can download LM Studio here. Ooh, and you can download, oops, it is struggling. Ollama here. Um, and Hugging Face, hopefully you have your API key by now, but you can also get that at huggingface.com. But let's talk about secure solutions. So ChatGPT and most LLM providers like Gemini, and even if you use some open source models like Llama online on their own servers, they will by default use those conversations for future training. Whether or not they actually use your data for training, of course, is if your data got selected, but generally assume that they might use it for future training. So any requests or any, messages that you also send through APIs to these chat models and embedding models. This is really important because most people just think, oh, I'm not using an LLM, so I can just use the embedding model provided to me by Hugging Face. Even though these models are kind of taking your data and converting them into these numeric representations, your data is getting leaked in that way as well. So even for embedding models, your data does get leaked. So when working with secure data, alternate approaches are required, and these either look like enterprise contracts with Microsoft, Azure, OpenAI, or open sourced models like Llama, and the others. So this is the sort of data classification guide that Vanderbilt Cybersecurity offers. Your university or organization might have something similar, but generally they tend to follow pretty much the same format for the same types of data. So there tend to be four levels. Level one is the truly non-sensitive data. This is data that's intended for public release. These would be like publicly available data sets like stuff on Kaggle. This would be data that you truly, as a researcher, don't care if it just happened to be on, a public GitHub repository or just out there on the internet, which is almost always never the case. But if you are working with that kind of data and you really don't care, you can use things like ChatGPT. Level two data is kind of more close to what researchers usually work with, which is institutional use only, which is private to the institution, not available to others without permission, which is unpublished research data, institutional documents, blueprints, stuff like that. Level three is restricted data. This is confidential by some contract or law and cannot be shared without prior authorization. And this is, data protected by NDAs. So this could be just, any data that you're using as a business. This could be protected health information, so PHI, HIPAA data, FERPA data. If you're working with any sort of student data, that is definitely restricted. And then if you are in the EU, GDPR, you have to follow all of those laws. So any of that data is also restricted. And then level four is sort of the really classified information. So this is if you were working with the government and you're a government related data. This is confidential by law and contracts and does often require bespoke security requirements. If you're working with law enforcement, the military, any sort of classified information, you will almost certainly not only have to use stuff locally, but the devices that you're using locally would also need to meet certain restrictions and requirements. So kind of things to keep in mind. I am seeing a few messages in the chat. I will take a look. Okay. Um, all right. So, what are the solutions when it comes to these various data classifications? So, level one, public use. So you can use all chat models, all embedding models through APIs, UIs. You can use all sorts of training solutions. So you can train locally. You can train using the OpenAI fine-tuning API. You can also send your data out to for a model to get trained on. I know Hugging Face does provide that option as well. So when you're using sort of level two institutional only use data, this kind of again starts varying by needs and preference. A lot of researchers that I've worked with, even though they are using unpublished data, their data is still, not particularly private, so they're okay using things like ChatGPT. But you do have the option of, opting out of training use by ChatGPT. So every once in a while, you'll see a little checkbox at the bottom of your ChatGPT window that says, "Don't use this chat for training." So you may want to do that. So that's usually available in sort of a paid ChatGPT account, or if you have an OpenAI team account, you can kind of opt out. The other option is, of course, institutional access or enterprise contracts. Vanderbilt has those with Microsoft, Azure, and OpenAI. That's why we're able to provide you with things like GPT-4o on Amplify. So Amplify is just a good go-to place for researchers at Vanderbilt. You won't need to worry about any of this. Amplify is also does work for data levels up to level 3. So that kind of covers almost most of the data that you would be working with as a researcher. And then, of course, you can use open source models. You can store your data. So another thing to think about is when you are working with uh, LLMs, you're probably storing this data somewhere on a computer. So you've got to be cognizant about where that data storage solution is as well. So if you're at Vanderbilt, you can use sort of our cluster to store your data on Acre or other approved storage solutions. You can also use local or hosted vector stores. This is what you would when you're creating a RAG interface, and we'll go into the details about RAG in week 3. But if you're using sort of a RAG interface and you're storing your data as embeddings somewhere, you can use both local or hosted vector stores. And then if you're trying to train your model, you can train it on Acre, you can train it on our DGX A100s that we have at the DSI that you can get access to using compute grants. And of course, you can train on Google Colab as well. Now, when you start moving into restricted level 3 data, you do really want to access LLMs through sort of enterprise contracts only, and luckily Amplify works for that. So Amplify would definitely be your go-to solution. But you can also use open source models locally. You can store your data on Acre easily without questioning it too much, or other private servers if you have your own. Again, local or approved vector stores, not hosted. And then you would want to probably train on your organization's local compute cluster or a private server if you have that. And then if you're working with really critical data, you really are boxed into using only open source or really custom models, because even some open source models limit the way that you are allowed to use those models. So if you've ever used Llama before, you will see they make you sign sort of an agreement as to what you can and cannot use those models for. So you might want to look at that. But if you are using sort of critical data, I would lean towards using custom models that you train from scratch and custom data solutions. So any quick questions about that and how that might relate to sort of the data that you're working with and the organizations within which you're working? And feel free to unmute or put it in the chat. Cool. So you might be thinking, I can do all of this, but what are the limitations of working locally? And there are quite a few. So obviously, most open source LLMs that you can run locally will probably not be as good as some of the state-of-the-art models like, well, this is has not been updated, but O3 or O4 or Claude. And the proprietary models are almost never sort of, you can never run them locally because just they're so large, you won't even have the compute to be able to run them locally. the exception here, thankfully, now is the model DeepSeek R1 and all of its versions that have come up recently. These are models that can still more reasonably fit onto hardware that you or your cluster might own, and you might be able to run these locally, and its performance does rival that of O1. So you can get so now these models that you can run locally are getting a lot better. And I expect that they will in the future continue to kind of keep up, just maybe a version or so behind. But the biggest thing is that you really are limited by your hardware. Running or training full parameter large LLMs requires multiple GPU nodes, if not multiple racks. And so the solutions that you have are enterprise contracts through AWS or Azure, which give you a secure instance for these popular proprietary LLMs. So the way we're able to use GPT-4o with level 3 data at Vanderbilt is because Microsoft is running those models on a specific server that they're kind of honoring to not share with other users. So that's kind of one really good way to get access to those models in a secure way. The other option is using smaller parameter fine-tuned models. And you can do this locally as well, and we'll go into how to do that in week 3 as well. You can use distilled versions of larger models, and distilled versions are essentially, distillation refers to a knowledge transfer technique where they use a larger model to train smaller, more efficient models. So it learns from the larger, more powerful model and helps compress the knowledge of the larger model into a smaller one while mostly maintaining the performance. So these distilled versions of larger models like Qwen 32 billion can be really, really powerful as well. And then, using larger models with lower quantization. So quantization is another technique that we use to reduce the memory footprint and computational cost of running these large language models, which essentially you take the weights of these weights and activations of these neural networks and convert them into lower precision formats. For example, reducing it from 32-bit floating point to 8-bit integers, which essentially reduces the size of the models, speeds up inference, lowers the latency of the models, and most importantly, in my opinion, reduces the energy consumption, while mostly keeping a lot of the performance. So these can be very, very powerful. And then finally, using parameter efficient fine tuning, which is also a technique that we'll go into in detail, where you just take a model and just fine tune it, fine tune parts of it to make it more appropriate for the domain that you're working in. Questions about any of that? Will anything above level 1 require costs? So yeah, as Dr. Bell said, on Amplify, it is available to a certain extent to most of the Vanderbilt community for free. But if you are a power user, they will give you a COA string and start charging you at some point. But yeah, unless you just have a good computer and you can use some of these models just on your own PC or desktop or Mac. And Miranda will go into how to do this. And some of these models do perform really, really well, especially for some easier tasks. I can use a 32 billion parameter model on my Mac that helps me with programming when I'm using some sort of sensitive data. So that can be really powerful. How can we use something like DeepSeek R1 locally? Yes, LM Studio, if you do have the compute on your machine locally, LM Studio will let you use DeepSeek R1. Ollama will do so too. So yeah, we will go into details on that. Cool. Running and hosting models locally. So we said Ollama and LM Studio. Miranda will go over that real quick, but I'm gonna quickly switch my screen share and take us to our GitHub repository and go over this notebook that we have called local inferencing. And you can also open this in Colab. But I just kind of want to show you how easy it is to run these locally, especially with Colab. If you're working with level 2-ish data, this is a very, very powerful solution because you do get access to some really good compute at sometimes free, if not just a very, very minor cost. So here's just 2 chunks of code. The first one is a Hugging Face command line interface login. So I'm just going to run this, and it's going to give you a warning that it wasn't authored by Google. It was authored by me, so you can be sure that this does not contain any viruses. But you essentially run this chunk. It'll connect you to And the only thing that you need here is a GPU backend. So currently, by default, I get put on a T4 GPU, which is pretty good. But I can also get an A100 because I'm on Google Colab Pro, which is very powerful. This is like the best GPU you would need to run most small models. So lots of options here, and I only pay about, I think, $4 a month for this. So very cost-effective solution, and you get quite a good amount of compute. So I'm just on a T4. I don't need the A100. I'm gonna go in here and quickly provide it with my API key, and you'll just paste that in there. I'm not going to say this is a Git credential because I don't want them to have my API key. And now it just really takes these like 6 lines of code to inference on Meta's Llama 3.2 1 billion parameter model. So all you need to do is use the transformers library. This is another library provided to us by Hugging Face, and use the pipeline function. You'd provide the ID of the model. So let's just go to Hugging Face real quick. And let's go to models up here. And here I can see, there's tons of models. I want to specifically look at Llama. Okay, I can see there's tons of Llama options available. I'm gonna go look at, let's see, Llama 3.2 3 billion parameter model. All I need to do when I come here is copy. Where did it go? Ah, right. Just copy this name up here. There's a little copy button. So now this is all I need. The one thing that you'll see here is this is a gated model and I have been granted access. If you come to this page or search up any Llama model, all you need to do is provide them with an email just to know they're keeping track of who's using these models essentially. So you can get access to this model for free. Come back here. I'm just going to paste that in. Here I have the 1 billion parameter model because it's quick to load. And then I just follow this. There's a pipeline function provided to me by the transformers library. My goal is text generation. I'm passing in my model. I'm here converting. I'm telling it that the model is in 16-point float, and I'm mapping it to my GPU. And all I'm saying is pipe, the key to life is blank, and I want it to fill in the blank for me. So what it's going to do real quick is it'll import the libraries. And once it imports the library, which will take a second, cool. The first thing it's going to start doing is start downloading stuff. What it's doing here, it's downloading the actual model weight so it can run it locally on this T4 GPU. So it is still running it locally. You're not using these models out on some server. So it is inherently a more secure option than putting your data out there. But again, I would only use this till I have, level 2, maybe in some cases level 3 data. It really depends on what kind of data it is and what IT thinks that you should do with that kind of data. But essentially, it downloaded the model, tensors, the weights, all the good stuff, and then it generated the text. The key to life is not to be afraid of the dark, but to know that it is there. And then it goes on to continue because this is not a fine-tuned model, so it's not really, it's just a base model is going to continue generating text until you tell it to stop. So that's how easy it is. So you can come here, swap this out for any other model on Hugging Face, and it will work locally. And again, you don't have to use this on Google Colab. This code works locally as well. So if I had a GPU on my computer, an NVIDIA GPU on my computer, I'd be able to run this code locally as well. And let me go back to the chat. Let's see if there's questions.
Just having little conversations about data security. I think one person did ask if you had suggestions for non-Vanderbilt secure platforms. I suggested Microsoft Azure kind of does, but yeah.
Yeah, Azure is great. You'd again need some sort of contract with them. Yeah, I would say if you need to use some of these larger models with secure data, I would reach out to these companies to actually set up some contracts. Your organization might already have them. Otherwise, you can run some pretty powerful models on some relatively inexpensive GPUs. So if you have, the main thing is your GPU needs a lot of memory. So if you have a GPU which has, 16 gigabytes plus of inbuilt memory, you should be able to run a pretty good chunk of these smaller LLMs that are powerful for simpler tasks. And I believe that is all I had. Miranda, if you had anything else to add.
Yeah, I think that's great. Oh, and one more question just came in. Can we get access to the Llama models without access through Vanderbilt, as the example you've done is running locally?
Correct. Yes. Llama models, you can get access to them without needing to be part of Vanderbilt. All you need to do is go to Hugging Face and provide them with just an email ID. They just want to kind of keep track of who's using these models. And then the example that I ran through is running locally, but it's running on the GPU that Colab gave me. My Mac doesn't have a GPU, so I can't run it locally. But if you had a PC and you had a GPU, CUDA enabled GPU, you should be able to run that exact same code locally. My access token there was just giving me the ability to download the model from Hugging Face. I believe you should be able to just use a write token as well. I don't think it matters that it's right.
Yeah, the basic tokens are read and write. Read allows you to download, or read allows you to view models, and then write allows you to train models and upload stuff to Hugging Face. So I generally recommend, if we do a workshop, for everyone to just get a write token, because we will be training eventually, not today. But it sometimes confuses people to ask them to get both a read token and a write token. But write has all the permissions that read has.
Oh yes, and people running into issues with LM Studio. Yeah, Intel Macs don't run LM Studio, unfortunately, so Ollama might be your best bet.
Awesome. Well, thank you so much, Umang. That was great and wonderful introduction to some of the tools we're going to be looking at. So we're going to take a break. And then when we come back, we will take a closer look at LM Studio and a little bit at Ollama. There's not a ton to show on Ollama because it's very terminal based, but I'll definitely show you LM Studio and how to use it. So if you're not able to access LM Studio, please enjoy watching a fun movie about LM Studio with me. And then otherwise, we'll talk about, how you can use these different apps. So let's see. Oh, and I see a question about an API key. Just real quick, seems you need to save your Hugging Face token into Google Colab as a secret key to work. You can do that. That is one method, but you can also certainly still use the method that I put in the notebook with Git Pass. So those are just two different methods to do it. Some people prefer one, some people prefer another. Yeah, all right, so let's go ahead and take a 10-minute break. We'll be back at 2 minutes past the hour, so 12:02 for Central Time people. And then after that, we're going to get into some more hands-on stuff and look at LM Studio. And then after that, we have a presentation from VUIT. So, all right, see you all in 10 minutes. All right, welcome back, everyone. Quick break. So now, oh, to the wrong one. Okay, so now that we have talked about some of those security issues, as well as some tools you can use, kind of an overview of those, we're going to get into specifically using those tools. So before we get started, if you'd like to download LM Studio, you can go to lmstudio.ai. And that is the website where you can download it. Like we said earlier, you have to have a Windows machine or a Mac with a M chip in it, or Linux. And so if you don't, then you'll just be following along with me. Another thing you can download is Ollama. However, that is entirely terminal based. So if you are someone that's not as comfortable using the terminal, that won't be as helpful to you. Of course, you're welcome to learn. However, I encourage all sorts of terminal users. Um, so, does anyone have any questions that they thought of perhaps during the break that maybe we didn't address before where we left off here? Great. Feel free to ask those as I'm going. Now we're going to move into more of a demo portion, and this isn't as much of a demo where I have a finished product or an ish product like last time. This is more of just me showing you kind of how these different softwares work, and we can kind of explore it together. So first off, you can go to LM Studio, download whichever one works for you, but they also have a really nice docs section on their website. So if you like what you see where I present it and you want to learn more specifics for your use case, I'm sure that you can find something on their docs that helps you with it. And actually, now I'm seeing LM Studio Python is available as a package now. I did not know that. That's really cool. So that's new to me. Like I said, this stuff changes all the time. So check out the Python package if you're interested. But LM Studio Desktop is what we're going to be using now. Okay, so if you download LM Studio and just open it up, this is something like what you're going to see. You can go to it's got a lot of information for you. And let me expand this here. This has a ton of information for you. And so it can get overwhelming if you don't need all of this information. That's okay. Mostly what you want to look at is you can search for models. So what this is great uh, for is that you can go over here, and this is a tool to use models locally on your computer. And so you can choose the models you want, like we said. So it kind of has some staff picks here, but this is a great, just a great software if you want to run inference locally on your computer. So you want some sort of chat GPT like interface, but completely running on your machine. It's not on the internet. The model is completely the model is completely running on your computer. So that does kind of limit you to what your computer can run. But let's go ahead and take a look at it. So this is LM Studio. When I load it up, yours might look a little different. But let's say we want to find a model. So they've got some staff picks here. You can go to this little magnifying glass, that's the search bar. And you can go to model search, find a model. And so they've got the latest Gemma, they've got Quinn, and what you want to look, and it'll even give you some options for downloading them. So we have all of these models, and notice it says 4 download options available for Quinn 3 235 billion. This one it says is likely too large. Yeah, I think 235 billion is maybe a little too large for my computer. But so it'll give you a couple options. And what are these different download options? Well, those are different quantizations of the models usually. And what a quantization means is that they took the large model and then they kind of compressed it. So like kind of like if you have a zip file or something, you can kind of compress it, except you maybe are losing a little information, but it's not going to affect the model performance too much. So that's what quantization is usually just making it fit onto your computer. So let's look at some smaller ones. So what you see here is a model name and then something B, right? And those are usually the parameters. So they'll have model name and then the number of parameters. That's loosely, you can kind of correlate it to how many calculations this model is going to need to make for something, or like that. It's not really going to make that many calculations, but that's kind of You can think of it that way, as this is, how many connections it has or how many parameters it is taking in with each thing that you're sending it to. So large numbers are obviously a little harder. Luckily, it tells us what's going to work with our hardware. So I'm going to try to just oh, I have a question from Mohsen. Yes.
Yeah, thanks. Miranda, is there a rule of thumb as far as, let's say we're trying to do this locally, like you said, like a rule of thumb of how much GPU RAM or something versus, parameters, and therefore like, so we can kind of say, okay, anything 3 billion and up is too much for me, for my computer to run locally. And then I guess follow-up question is, what happens when you get out of this? Is the model downloaded permanently on your computer, or is it just temporary?
Yeah, it's permanently downloaded on your computer. So however much RAM, so this is 111 gigabytes. So if I don't have 111 gigabytes free on my computer, then it just will not. I don't know exactly how it handles that, if it has some sort of fail-safe there, but it will absolutely not fit on my
And
computer.
that's storage, right? That's not
Yeah.
GPU RAM. Okay,
No,
so
that's just like storage on my computer.
and then on top of that, though, they always talk about, from what I understand, you need to have like either unified memory or some GPU RAM to actually run the model. That's usually a binding constraint. Is that true, or am I confusing it with
Yeah,
something else?
usually. Umang, do you have more details on that? You probably know more.
Yeah, so LM Studio for the most part, it's very good at looking at what kind of hardware you have and telling you what kind of models you'll be able to run and not. Yeah, the
Oh, okay.
biggest constraint here is your unified memory on your computer. So I would say, honestly, I think even though that says 111 gigabytes is the download, I would think that that's kind of also around the amount of memory it's going to want. Um, yeah. So for most of these, it tells you will fit on your computer. Some of them, it's also LM Studio is able to offload the model between your CPU and your GPU. So some of them it'll offload fully onto your GPU, some it'll keep parts of it on the CPU and parts of it on the GPU. So there's a little bit of flexibility as to how big of a model you can put there. It depends on how fast you want it to work. So if you put the entire model in your GPU, it's going to be much faster than if it's doing some of it on the CPU and some of it on the GPU. But LM Studio is very good at identifying what your hardware is, and then it'll, for each model, tell you will fit on your GPU, will fit entirely on your GPU, or likely too large.
Awesome. Okay, thanks. I didn't know that. It's very helpful.
Yeah, great questions. And just to, I think you also asked, like, is there a rule for how many parameters versus how many GPUs? I don't think there is. Is there? I mean, it's generally more parameters, more resources you need, but I don't know that there's
Right.
like a
Yeah, there
strict,
might not be a rule because again, you could have a 32 billion parameter model that is full 32-bit floating point, or it could be
right?
8-bit integer or 4-bit integer, which drastically reduces the size, and then suddenly it fits on your computer. So it depends on both the number of parameters on the model and its quantization.
Yeah.
Yeah, right.
Yeah.
So,
So
but I guess what I was thinking is, let's just, and maybe I'm doing the math wrong, but if it's a 4 billion and it's usually 32-bit, and now you've quantized it to 8-bit, is it safe to say that's the equivalent of 1 billion parameters, or um maybe it's more complicated than that?
So
But
the
yeah,
number of
when
the
I
number
was
of
thinking just the
parameters
total.
Yeah, the number of parameters remains the same when you quantize the model. It just the like
Yeah,
actual
that's true.
number weights just go from 32-bit floating point to smaller numbers, which makes them more memory efficient. So, um, I think so. For example, I have a 32 gigabyte memory, and the most I'm able to comfortably run is a 7 billion parameter model. And you'll quickly figure out if your hardware isn't changing around a lot, you'll quickly figure out that mostly, I can stay, if I'm under 14 billion parameter size models, I'm good in that range with varying quantities.
What was the number you said? You for 7 billion, you have what?
I have a 32 gigabyte Mac, and I'm mostly happy running a 7 billion parameter model fully on GPU.
And that's unquantized.
Unquantized, yes.
Okay, great. Thanks. And what's the intuition behind the inference time? Is it linear with the number of parameters, or is there any rule of thumb there? Because I'm guessing a smaller model is faster at inference.
Yes. I don't know if it's linear actually. Shara, do you know?
Yeah, I
I
don't
don't
know
know
if
how
it's,
it scales.
yeah, I'm sure. Perhaps we can do some after hours
Don't
calculations.
Yeah, and I
don't
think a great person to ask about this is Jesse next week, because
Yeah,
we'll be talking about all the models in concert, and especially about the reasoning models, which have a different kinds of not a different kind of inferencing method, but a different way of going about generating answer. And so I think he'll be really great in answering that.
Okay, thanks.
yeah, short answer summary. All models are different. Some of them are more memory efficient, some of them are less. In general, more parameters means a little more difficult, a little more resources you need to be able to run it. So yeah, wonderful questions. I love that. Thank you so much. So you can see, so for I don't quite remember what the memory is on my computer right now, but I do have an NVIDIA GPU and on a desktop. So mine will be a bit beefier than a laptop, for instance. But I'm still gonna try to choose, a model that's a little better. So maybe 1.7 billion is great. 0.6 billion, right? So it's got some options for you. So if this doesn't look like it's going to work for you, all you do is select your model, and then there will be something download. You can, if you want, choose one of these that you want to download. I would say the default one is pretty good, unless you definitely know like what you're doing, or maybe like this, because you can see the memory kind of differs, like it goes from 800 to 400. This is something that you want to look into, do the research on your own. Otherwise, just kind of download the one you want. Umang, were you saying something? Oh, okay, cool. And so you can just hit download here. I already downloaded 1.7 billion. And once you download it, you'll have this option to say use in chat. And so this is just an example for Quinn, but let me show you. Someone asked about Llama. You can type into this and find which one you want. Oh, look, DeepSeek showed up here. But now we can also look at Llama. You can choose a bunch of different ones. These all just have different maybe quantizations or different training, different instruction fine-tuning. So you can really look into what models you want. But let's go back to just where we started. And the staff picks are pretty great to play around if you're unsure where to start. And so here's Quinn 3, 1.7 billion. Now I could say use in new chat. And now this looks right, very much like Claude or ChatGPT or something, and has some example ones here. It says, you can show prompt suggestions. You can upload a file, attach a file, change around what role it's going to have. I'm just going to kind of use this same example here. Write a Python script to generate student grade data, like just something really simple, and it's going to think about it. What's interesting about Quinn is you can see its reasoning here, because it is going to reason. So it says, okay, I need to write a Python script that does this. First, I should do this. Oh, the user didn't specify the number of students. Maybe I should make it flexible. So it's going to kind of talk to itself here. And if you're interested, oh, thought for 16 seconds. And if you're interested, you can look around on this. But like I said, what's great about this, it thought for 16 seconds, and now it's doing stuff. And this is all just running locally on my computer, right? You're not having to pay for ChatGPT. You're not having to pay anything. As long as you have these resources available to you, you're able to do this. And it's all just on your computer. So, thinking about how if you're energy conscious, and maybe you're a little scared of you don't want to use a huge model if you don't need it, you can just do really easy things pretty locally. So now it's going to generate this script for me. If I wanted, I could take that as example output. I mean, look, this is really cool, wonderful. So we can, kind of chat with this and make some stuff. But where some of these pitfalls of LM Studio are is that it's really great if this is what you want. If you want an interface for interacting with these models. Like you basically just want ChatGPT or Claude, but on your own computer. This is wonderful. Like I said, the security is really just how secure is your own computer. And it's really just resource dependent on what you have on your own computer. You can customize a lot of stuff, look at logs, get more model information. You can load different models. So I can actually have Quinn and another model loaded and chat with different ones. So look here, it says eject. When you eject a model, you can choose a different one. So these are the models that I have downloaded to my computer. So now if I want, I can switch to Llama, and that'll let me chat with Llama instead. So if there's one that you like better, you can chat with one of those models or just compare what they have. I mean, there's just a lot you can do, but I would say that overall it's pretty simple to get started with. So you can make this as easy or as complicated as you want with LM Studio. Now let's talk about some of the pitfalls with LM Studio that I think they're kind of working out now. One is that sometimes you don't want this. Sometimes you want to develop with these models that you can download onto your computer. And so you don't want to chat with it like ChatGPT. You want to create your own tool. You want to create your own app using something like LangChain, but interacting with your own model that's very local. So if you're developing code, this interface is not great because it's very just constricted to this interface. Now, if you want to code with your own custom model, that is where Ollama kind of comes in. So we'll look at that very briefly. Now I'm just going to check the chat to see if there's any questions about this for now. Okay, looks like most of them have been taken care of. All right, and so that is LM Studio. And if you have questions, feel free to ask about LM Studio. It's really great. I highly recommend you just play around with it. Now let's talk about Ollama. Now I can't see. Okay, so if you go to Ollama, they have a website that's pretty good, and it kind of shows the different models that are available here. Really cute llama. But what I really like is their GitHub page. So you're going to notice that we use a lot of GitHub here. And so if you're not super familiar with it, don't worry. A lot of times you can use it just like a website. It's just like a website that also shows you some files on it. And really great for programmers. So if we scroll all the way down here on Ollama to where you see this picture of the llama on their README, you can have different options for downloading Ollama. And so now, what is Ollama? Well, Ollama allows you to programmatically interact with these models. So as opposed to LM Studio, where you had a whole user interface, Ollama is a way for you to do something like that in the terminal or in your Python code or whatever language you want to use. So instead of having a ChatGPT-like interface, if you're wanting to do your own app, create your own application, you need to connect to a model through your own application, not through some other GUI, right? So you can download Ollama, and they have some pretty good getting started information. So, you know, how do you run Ollama? How do you download a library? What models do they have in their library? So you can see they've got Gemma 3, DeepSeek, Llama 3, Mistral, a bunch of stuff, Code Llama. And it even tells you, you know, how do you find the different files? What files can you import? So if you created your own model, you can just convert that to this kind of file format, and you can even use that in Ollama. And then also looking at prompts, how do you want to customize this prompt? Like I said, this is all code-based, right? So like when I said there wasn't much to show, this is what I mean. It's all code-based. So I really recommend if you want to use Ollama that you have some coding experience, or you're at least willing to do a lot of research into how it works, how you can use it. But this is really great if you're a programmer and you just want to get started using your local models for inferencing on your own application. So you know, you can create models, all of these things. Really great. So what I recommend for this is if you're writing a Python application, normally maybe you would make a call to the OpenAI API to ask a question, but your data needs to be secure. It needs to be local. So instead, you're going to go with a local model, right? So that is on your computer. You run the code on your computer, and it works great. And just some information about how to chat with that. So like I said, I'm just going to show this really quickly because I think there's not a lot to show. And maybe one day we'll get some good example notebooks on here, but this is really just a quick start to Ollama. So let's see, it looks like the chat is very active. So I'm going to see, don't send me private messages because I may not see them, but let's see. Okay, good question. This was sent to me private, but I did see it. What's the benefit of running these models on LM Studio versus importing them into Colab? So for one, Colab, not local. So if you need data security, Colab is not it. LM Studio is completely on your computer. Also, Colab is a coding environment, so you're not going to get any sort of user interface. While LM Studio is just a full-on, user interface here, it looks just like ChatGPT. So it provides a UI and it's local. All right, any other questions that I missed? Looks like we got them all. Okay, wonderful. Let's see, is our guest speaker on yet? Have we seen him log in?
I'm here.
Oh, you're here. Hello. I couldn't see you. Welcome, welcome. Well, if you're ready to get started, I believe we're ready for you.
Cool. Let me
All right.
let me get the screen share going.
Okay, perfect.
While I'm doing that, hi everybody. My name is Lee. I work here at Vanderbilt University. Now I can't do multiple things at the same time.
Oh, let me make sure that I
Uh,
enable you to share. Oh, you got it.
Can you guys share the
Perfect.
screen? Cool. All right, let me do that. How about that? Cool. All right, guys. Like I said, my name is Lee. I'm a principal cybersecurity analyst at Vanderbilt University and in the Office of Cybersecurity in VUIT. Now, thank you for having me here. The topic that I'm having is not remotely as interesting or hands-on as what them talking about, but compliance is very important, and when you come to security and privacy. So anyways, I have 20 minutes to cover some generative AI use cases that we see here at Vanderbilt and their common risks. And I'll also touch a little bit of the data classification policy and minimum security standard. As Uma probably talked about the data classification policy a little bit, but I will be mainly concentrate on the standards that come with it. I'll talk about the security controls review that we conducted for Amplify AI as an example. So, first of all, within the last couple of years, our security office has had experience with many different AI use cases in teleconference assistants, interview transcriptions, process automations, and workflow optimization tools, conversational AI, and chatbots, generative AI and LLM, and automated communication and AI-generated content tools. I know this group probably have their hands on trying to make a lot of tools, and I guess one of the elements will hit what you're developing or what you're trying to achieve here. And each use case comes with its own different risks, ranging from technical risks, financial risks, reputation risks, and operational risks. For example, like teleconference assistance comes with a big data privacy and compliance risk. Generative AI and LLM often comes with misinformation, data integrity, and data poisoning risks, which AI generated content may be manipulated by false information. And the LLM may be vulnerable for adversary inputs. Process automation tools may process and store confidential information, posing risks if the data is improperly handled or exposed. And the key point here is that all AI tools that add into Vanderbilt ecosystem will naturally come with inherent risk. Well, risks can be mitigated in so many ways. That's why we're talking about. Then that's what we're talking about here. And then I saw some examples that before my talk, and so I'm confident that to say that we're definitely not saying that no AI tool should be used. Well, some of the security and privacy professionals might come out that way, saying, "Hey, don't use this, don't use that." But we're not here to say that that cannot be used. Instead, we're just trying to inform our community and invite you guys to think about the risks with all different use cases when you think about the benefit, right? In one of the most important element of risk analysis, risk analysis is looking at the data that's involved in cybersecurity. Our risk analysis follows the data classification policy, which was introduced by Uma earlier. I believe you showed this, and there's a link attached. Now, Uma had covered the the right solutions, right, for different level of data. Now, allow me to just introduce it from a risk perspective. Each level of data comes with different risks if it's mishandled. For example, the risk of mishandling level 4 data is severe due to its legal and compliance risks. Financial penalties and legal consequences are normally enforced in this type of data when it's breached. With our data classification policy as a North Star, we developed 3 categories of security standard, which maps to each data classification. This is us trying to operationalize the institutional data classification policy from a cybersecurity perspective. The minimum security standard was developed within with the NIST 800-171 has guidance, FIPS 200 has the methodology, and it's very boring, like stuff that compliance, the government trying to make us to do to stay in compliant. But our goal is simply to all the controls the government mandate and map them into different type of data. As you can see, if you're handling level 1, level 2 data, only 18 controls out of 110 will apply. If you're handling level 3 data, 74 controls. If you're handling level 4 data, that would be 110 plus whatever that the regulation you're attached to. Out of the 4 levels of data, level 2 data has the most volume. We know that because it's Vanderbilt owned, but not public. Most of the data are staying level 2 data, but level 3 data is has the most volume as far as the sensitive data. Therefore, let's just zoom in a little bit on security controls for level 3 data. And level 3 data is subject to 74 total controls, which are across all 14 control families. It includes technical controls. I see chats popping up, but I have one screen, so I can't really see them.
It's all right.
Maybe
We're
I'll.
handling them.
Yeah, we're
Oh, perfect. Perfect. I can come back to any one of them after finish the presentation. One screen is not like best way to handle things, but it's an office day, so some of the offices. Okay, all right, back to level 3 data. Level 3 data covers the security controls, covers all across all 14 different control families, as far from access control to configuration management, identification, authentication, and risk assessment. Those are very dry stuff language in the control book. But let's see, just click that. I'm trying to use an example to show how that works, and probably from a different perspective on if you're developing an AI tool or if you're using an AI tool, this could be all applicable. Now, let's see, Amplify AI, I think most people know it, and it's a VUIT AI solution leading by Dr. Jules White and VUIT Cloud Architect Alan Carnes. I mentioned a little bit earlier that system assessments are, let's see. Okay, yeah. Risk and control assessment relies on multiple different established risk management processes. At the same time, it's a collaborative effort with multiple different teams within the university. So to start the assessment, we learned the architect, the infrastructure and architect of Amplify. We first picked out all the vendors that is involved in the system, and then as you guys introduced, like you can call OpenAI, you can call different models. Those are we consider as a vendor because some of them we share information with, and if you're running locally, that's different. Well, I'll get to there as far as data storage. Now, for vendors that's involved, like for Amplify, the vendors are OpenAI, AWS, even though they're giant companies, but we still look at them, especially our master agreement as Vanderbilt with AWS and Vanderbilt with OpenAI, because when we were using it with the master agreement covering it, and no data will be trained, no prompt will be trained. Those are promises from those organizations, and they have to comply with that. So our vendor risk assessment also looks at, is there a breaching history and how did they handle it? And some technical stuff like how do they handle penetration testing? How do they comply with industry frameworks? and all that. Then we follow the data, we look at where the data is stored, and we conduct the data storage assessment. So as Miranda just talked about, if you're running locally, it's as safe as your laptop, right? So that's your storage unit and how to secure that. In the case of Amplify, the data is stored in the VUIT managed AWS accounts. Different modules. And so a plugin here that for centrally managed storage solutions and other centrally managed IT functions, from compliance perspective, it is always easier to use centrally managed services because centrally managed services has already been assessed and reviewed for security and other risk functions, but this is looking from a risk and compliance perspective, and from operational perspective, you might consider something else, which means those solutions are approved, and by security and by other university risk functions. Let's see, in the case of Amplify, all data storage, security controls, and documentation are inherited from VUIT cloud services because it's centrally managed. So no further assessment are needed. If you dealing with any compliance, any sort of a compliance work, how documentation can be very mundane and a lot of work. So use centrally managed services, at least save you some time on documenting all that compliance requirements, and also all the configurations. And all that need to be done was to just for Amplify to enable a few monitoring, audit, and other services in AWS. If the storage or computational resources are not centrally managed, we will assess cloud vendors and their security configurations if it is in the cloud. And if it is on-prem, like let's say Acre, I think Umang mentioned Acre or HPC, and we will have to assess the servers and database security configurations based on their operating systems and storage methods. And a lot of more assessment needs to be done. Even for Acre, if you don't have different servers have different security configurations, not everything is the same, especially when you're getting into level 3 and level. I don't think Acre is even approved for level 4 data. So for level 3, then we have to look at specific configurations. Now, same has access control. If you build something, you want to give it to Vanderbilt University to use, then you can create your local access within the tool or just between your team. But Amplify did is to utilize our central authentication and SSO, so VUIT ID and your password. That way, they don't have to manage the whole access control side of the house, and they just use federated authentication and all that. And other technical control, other than technical control assessment, like I said, compliance is including a lot of administrative controls and documentation, big parts. For example, like cybersecurity training. So we have verified all Amplify team member have been properly trained in handling cybersecurity risks, and was verified during compliance and documentation and all that. So if you're building a tool, I'd say at least for the admin users in the tool that needs to be properly trained. You don't have to really take specific training saying has to be Vanderbilt cybersecurity training. Any other sort of training is going to be suffice for that purposes. Now let's see. After everything else you've done, then you have to really also look at the big documentation. It's called SSP, and that's required for a lot of regulatory requirements for compliance purposes. SSP is a system security plan. It's like a configuration of your system. How did you plan them? How did you plan to secure it? What type of access control you have, what type of data storage control you have, and it's a lot of documentation. And Amplify SSP, I drafted Amplify SSP, ended up being like 70 some pages, and it's very mundane, and don't ever, and I use the AI for it, and I don't want to ever do that again. That's where use Centrally or other part had already done the documentation. You can put them together, inherit the rest, inherit their controls. In the meantime, inherit their documentation as well. Now, the data disclosure agreement is very big too for privacy perspective. For any tools that you build, I would suggest that let your user know, if it's user facing, let your user know, hey, AI has been involved in this. I mean, and put it out there so they know it. Most of the states and federal government will require you to put out notification to the users. Let's see. So, okay. Lastly, we looked into the security scanning and monitoring functions, and we're not actually scanning and monitoring the data or the use of the tool, but we're looking into the potential cybersecurity risks that adversary could exploit. That is where when you build the tool, follow the data, how user access it, and if there's any adversary activity, how you can manage the alerts, how you monitoring all that. It's very important for when you developing tools. So, and
Just to, sorry, if I could just went real
Yeah.
quick, some really interesting questions in the chat.
Yeah.
Some of the folks here are not like specifically from academia or from Vanderbilt, and they're really interested in what you're saying from like a high level. So like they want to learn more about what the, like, especially your last slide, how that would relate to like industry or organizations like as a whole. So what if they're in like some company, like what of these would they expect to see, or how would they think about this in their own organization?
You mean this slide?
Yes.
Okay. So governance, right? Like we're managing cybersecurity and privacy in AI pretty much without a proper governance body here at Vanderbilt. Like there's so many different, for example, if you go to library's website, it has a guidance on how to use AI. If you go to, I don't know if Provost's office had published one, but our staff has one that published on how to use it. And a cybersecurity team and privacy team has to take lead on all this. If you're not academia, if you're in the organizations, it depends on what your role is. If you're in security or if you're in some team that you want to use it, you better get buy-ins from your legal compliance. And depends on what type of data you're handling. Is that the question? Like how do you use it or?
So the specific question I'm looking at here is what are specific, or what would be examples of industry standards and guidelines that would be the baseline requirements for organizations to follow?
It depends on what organization. That's why we have, so universities is some sort of a perfect example. So we have, I'm a student, I'm writing some paper, doing some homework, and that's non-sensitive at all to the public, right? To me, it's very, but to the public, it's not. And on the other hand, we have the most restrictive compliance framework in some area, the DoD contract, right? Like those have to be following NIST 800-171. So to the specific question, well, I'd say NIST 800-171 is the guidance that we're following, but it's only security. It's only security. NIST 800-171 only covers security. NIST 853 covers privacy. However, as far as I know, there's no tools to mapping between which like GDPR. I saw GDPR in there, and to map GDPR with 53, especially you add AI on top of it, like it's a chaos. Now, however, as an organization, you can define it, right? Like you own it. For example, what we did at Vanderbilt is we say, hey, we have 4 levels of data. Level 4 data, this is how we define it. Somebody could come in and say, hey, you're wrong, you defined it wrong, but we took a shot at it and we show evidence on why we're defining this is the most severe data and what type of control we put in there. The thought process, right? It's kind of like AI, like you wanted to know how did it come to the conclusion. If you can improve the thought process into every decision that you make, you have a framework. If you have a framework and outside even audit or any compliance work is based on a framework, they can question the reason that you're making decisions, but you can, as far as you can show them, you're in compliant. They might give you findings saying, hey, I really think that somebody could saying Vanderbilt 4 level of data to the level 3, you should have 80 controls, not 74 controls. And I can clearly show that we considered 74 controls, not the extra 6 controls you're mentioning, because we are specifically talking about academia and different realm in the university. So that's where the difference come from. That makes sense?
Thank you so much. That's a great answer.
Yeah, I thought it's boring until people have questions, right? And let me go back. Okay, let me see any other questions. Yeah, EU AI Act, yes, it is really extensive. However, like Dr. Bell, you're saying, we're a university, a lot of research are exempt from GDPR. It depends on which country and all that. So don't take my word. We always get OGC, our legal office, by to have them provide guidance on all this. So let's see, yeah, GDPR, yeah, NEST 800-171, thank you. That's revision 3, revision 2, actually revision 3 is out, I think. And also NEST had take a AI and privacy publication. I think it's due draft, but if it publishes, that's something we have to follow. And we are working with different departments to, thank you, different departments to trying to look at a privacy function at Vanderbilt, as you all know that how security, privacy is actually more into AI than in security. Security is just how you set up your configurations and stuff. But for privacy is how you treat my data, what is the acknowledgement, what is the disclosure, and all that. So yeah, that's something we're working on. Other than that, we do it's a perfect segue. IRB, AI consultation. Now, from a security perspective. Mainly I'm personally handling all those. So if you go to IRB saying I'm going to use AI for human subject interviews and all that, I'm going to use this tool. What do you think about it? And the IRB office is going to send it to us saying, hey, security, take a look at it. Most of the case, and we look at, hey, where you store your data? How do you do it? But end of the day, we have to contact our legal office saying, hey, they're doing this research on this frame. What do you think? So it's a collaboration. If we have our privacy office established in I don't know, next couple of years, things will be more streamlined, easier, and then we'll have a single point of person to contact. That'll be really nice. We published a video conference and transcription guidance. Basically, some of the tools, for example, like Read AI was pretty big coming up. It's a worm, like it's gonna record without notice. It's not gonna turn on saying tell you that hey, you've been recorded, and it's gonna send summaries to everybody who participates and have them register. So it's acting like a actual worm. So we took initiative, block it from at least from our conference video conference tools, Zoom and Teams. You cannot use like Read AI until they change their behavior. We might come back and reassess them, but they're just way too aggressive and it causes a lot of chaos for people. I had a meeting. I said nothing. I got a email from Read AI. I have a screenshot of my face and saying, "Hey, this is your assignment from this meeting." That's kind of creepy when that happens. And we do, like I said, vendor risk assessment. We are working with Jesse on looking into DeepSeek, and so far there's no guidance had been produced from that conversation, but we're leaning towards from a security perspective. Again, if it's a local machine and we had discussed how security goes on your local machine or on a local server, you are running it locally, you're not calling out APIs, you're not sharing any data, nobody's training on your data. It's as secure as like your laptop goes, right? Like, so for security wise, we don't have concerns, but there's no official publication saying where we stand as a university. And well, how to engage us. And we have cybersecurity at VUIT and our website and tickets. We're here to help, and this is why like I really appreciate you guys inviting me to come here and just share a few minutes, share a few thoughts, looking at things in a different realm. So I'm not a somebody over the other side of the email says, no, don't use this, no, don't use that. There's a reason behind everything, and we try to explain and all that. Like last time I had a conversation with Miranda is we're just craving for governance as everybody else, right? If somebody could provide clear guidance on higher education, this is where you go, and until that, Vanderbilt is going to have its own flavor of governance. Within Vanderbilt, academia and staffing is going to have different guidance, and even within academia, Peabody College and Owen is going to have different guidance. But the security concept of how to use AI, it's fundamental, very fundamental. Like, are you sharing your data? Is people training on your data? If you're sharing your data, is the other party responsible? And just very simple stuff like that. Okay, I think that's it. Let me see if you have any more questions.
So I did want to ask yet another question. I
Yes.
love like cybersecurity, but there were two really, really great questions, and they're like sort of related questions in the chat earlier. And they are about like more resources where people can learn more and provide those resources to other people who want to learn more. So I think there was a lot of enthusiasm about one of your first slides where it was talking about the different risks of AI and the different
Yes.
different like security risks. Where can people like learn more about that? Like where is there like a particular, I don't know, paper, or is there a particular group that does a really great job of like explaining it for the common person? Like what kind of like where can they go to learn more about that?
That's great, Dr. Bell. I mean, we're thinking about it at the same time, comes back to governance. And when there's no governance, part of the group is taking different initiative. I'm going to do this, I'm going to do this, I'm going to do this. But when it comes to guidance, people is all going to be like, oh, not me, not me, not me. Like they're not going to provide those type of things. And we're trying to work with different departments and trying to put something together as a general guidance. But the issue we're running into is different needs, right? We have to tear it down. It becomes a lot of work. For example, if we could say that, hey, if you're conducting this type of research, use this, then it's too very granular, very detailed, right? But we can't say that for, hey, all faculties follow this guidelines, because there's not a faculty being like, I'm not doing what they're doing, I'm doing something else. So that's we'll have to think very creatively on how to provide guidance and resources like that. But you're 100% right. On the very top level, just has sharing a culture of security and privacy and AI, and even ethic use of AI. We are working on putting something together and to share with the entire university. But until that happens, I mean, reach out. We would be happy to take the power that we have through the communication is if you reach out to us and you have some specific concerns, you don't know that, oh, this needs to be looked by lawyers, we can get you connected to lawyers. If this needs to be looked at by compliance people, we need to talk to compliance people. Sometimes those type of things sounds very like take a step back, right? Like it's very, I don't want to do that. I'm just, coding, writing my program and doing my things. But if you're thinking, if you're thinking about there's a market for it, the better you need to cover yourself from a compliance perspective to start with, even to protect your pattern and to do things start at, right? There's a lot of great examples of huge companies that had a testing code had password in it from 20 years ago, exploited, and the whole thing went south. So this should not be named, but it happens a lot.
Perfect. Thank you so much.
No problem.
Yeah, awesome. Thank you so much for presenting. For our audience, this is your chance if you have questions for a cybersecurity expert to answer. Here we are, whether you're in Vanderbilt or outside Vanderbilt. It's a really great opportunity. I think we're really lucky to have a cybersecurity office and coworkers that are willing to come do this and talk to us, because it really does make a difference to talk to people instead of just reading rules, right? So thank you so much, Lee, for coming and presenting for us. So are there any other questions, either for Lee or for any one of us over the security topics we discussed today? Really important stuff going forward that I hope you'll be able to apply as we move forward through AI Summer. So if we start, example code, and you're like, oh, but my use case needs to be local. Well, a lot of this you can apply going forward. So I think that's mostly what we have today. So if you have questions, feel free to stay on. Thanks so much for joining us today. We'll get this recording on our GitHub, and then we'll also have our office hours from 1 to 2 Central Time as well. So thank you all so much. If you don't have questions, then we'll see you next week. I believe Jesse will be leading next week. And thanks all. So any questions, feel free. Office hours is on this same Zoom. We're just gonna sit here until 1, and then we're gonna sit here until 2. Oh, and Lee, some people did ask if they are able to access those slides after this.
For sure, yeah, I'll share it with you. I'll email you and
Okay.
Umang about my. I can't wait to go back to listen to what you guys had talked about before I joined. I was volunteering for commencement earlier
Oh, great.
today. Yeah, it was really fun. So quick story, since nobody have any questions. I was at the bookstore.